Hi students, today we are going to discuss about interpolation. So here we are going to consider in this topic, we are going to consider the forward difference and backward differences, the new concept called as forward difference and backward differences. And using those forward and backward differences, we are going to derive Newton's forward difference interpolation formula, Newton's backward difference interpolation formula, and we also we are also going to study Newton's divided difference interpolation formula as well as Lagrange's interpolation formula. Right. So for Newton's forward difference formula and backward difference formula, we are going to define what is forward difference and what is backward difference. Right. Now, as I discussed with you in my previous video, see the process of finding curve passing through the points x0, y0, x1, y1, son of x and yn is called as interpolation. The curve obtained is called as interpolating curve. Right. It is like, see, you have done similar kind of exercises in your labs, in your physics lab as well as chemistry lab or whatever engineering labs. See what you did there for different set of tabulated values. See, maybe time may be one such variable or distance may be one such variable. See what you did at t is equal to t naught, you considered the value of the physical quantity and you got a t naught and concerned maybe you can say the force or the velocity v naught. T naught and v naught are my one set of points. Then I calculate or find out the velocity at t is equal to t1. So let that be v1. Then t1 v1 becomes my second set of data. So like that, we find out n such data at t is equal to tn. I find out vn. So tn vn becomes my such nth data. So here in terms of mathematical point of view, I call that as x0, y0, x1, y1, x2, y2, son of x and yn. That is, x becomes my independent variable. That is, I can choose x as at my wish, independent variable. So here there also the similar analogy is what? I can select time at my wish. That is, I can find out the value of v at t is equal to 0 seconds. I can find out the value of velocity at t is equal to say maybe 10 seconds or maybe t is equal to 25 seconds. So it is my wish. But velocity v depends on my choice of t. So v becomes dependent variable, t becomes independent variable. Like x is independent variable, y is dependent variable. So you can apply easily this method to your practical problems also. Right. So I go further. Let x0, x1, x2, so on up to xn be given set of observations and y is equal to fx be given function. Here see, this is a blunder I am telling. Y is equal to f of x is actually not known to me. I am just considering set of tabulated points. Here just to make you comfortable, I am assuming, see, y is equal to f of x is my given function. Right. Then method to find out f of xm, that is at unknown tabulated points. See, x0, y0, x0, x1, x2, so on, xn are tabulated points. Whereas if I give you unknowns, that is if I give you one value of x which does not belong to these x0 up to xn, so then that becomes the unknown tabulated or not tabulated point. So if I ask you to find out the value of the function at non-tabulated points, then I go for interpolation method. If xm, that is the point at which I should find out the value of y, lies within the interval x0 to xn, I call that as the process as interpolation. If xm lies outside the range of x0 to xn, then we call that as extrapolation. Right. See here also, as I told you, we are studying four methods: Newton's forward difference method, Newton's backward difference method, Newton's divided difference method, and Lagrange's interpolation method. See, of which we categorize broadly, we categorize these two into two parts. See, we consider two possibilities. See, x0 to xn, we consider two possibilities here. See, x0 to xn, they are divided equally, right? Or they are not divided equally. See, for example, if I say x0 is 1, x2, x1 is 5, x2 is 10, x3 is 15, x4 is 20. If I give exercise like this, what is your observation here? x0 is 0, right? x1 is 5, that means 5 minus 0. 5 minus 0 is 5. Then x2 is 10, so 10 minus x1, that is x2 minus x1, 10 minus 5, again it is 5. x3 is 15, 15 minus 10 is again 5. So like that, these points x0, x1, x2, so on up to xn, they are equally spaced. That means if you know the common difference h, see in my case I considered the example as h as 5 in my example. See, if I know the common difference h, and if I know the value of the point, initial point x0, and I can write down all those x's. That is, I can go up to xn. See, what will be x1? x0 plus h. What will be x2? x1 plus h. What will be x3? x3 plus h. So like that, I can go up to xn. So such points are called as equally spaced points. And if there is no common difference, haphazardly, see x0 is 1, then x1 is 3, x2 is 7, then x4 is say again 3, then x4 is again 10, then x5 is say 20. So like this, if you find out the differences here, they are not same at all, they are different. So x1 minus 3 minus 1, 2, then x2 I called as 7, 7 minus 3, 4, then x3 I called as say 10, then 10 minus 7, 3. Then I said 15, 15 minus 10, 5. So there is no common difference here. So such tabulated points, they are called as unequally spaced points, right? So I'm going to use, if x0 to xn, if they are equally spaced, I am going to use either Newton's forward difference formula or Newton's backward difference formula. If x's are not equally spaced, that is, if unequally spaced x's are there, then I am going to use either Newton's divided difference formula or Lagrange's interpolation formula. So broadly, whatever the methods we are going to study, I cannot solve all the problems using one formula. So it depends on the set of values, that is set of x's given. Right. So let me first introduce, let me go to Newton's forward difference formula and backward difference formula. I consider the case where x's are equally spaced. So for that, I should know what is forward difference and what is backward difference. See, as you know, if x0, x1, so on up to xn are equally spaced, let y0, y1, y2, so on up to yn, they are the corresponding values of xi. As per some unknown function, the function which is not known to me. Then I define the forward difference of the set of values y1 to yn as del of y0 is equal to y1 minus y0. That is what I did here. Del of y0, I considered the next value of y0 minus the value of y0, that is y1 minus y0. Similarly, del of y1 will be what? I consider the next value of y1, that is y2 minus the difference y1. So y2 minus y1 gives me del of y1. That's why it is called as forward difference operator. So forward difference. Why it is forward difference? See, del of y of k, if I consider any general point y of k, if I consider, what I should do? I should go forward and I should consider the next value of y. So what is the next value of y? Yk. Next value of yk will be yk plus 1, right? So the difference between yk plus 1 and yk gives me the forward difference of yk, because I have considered my point at yk plus 1 minus the value which I consider, that is yk. So yk plus 1 minus yk gives me the forward difference for yk. Right? So this is how we define. See, del of y0 is y1 minus y0. Del of y1 is y2 minus y1. So on, del of yn is what? Yn minus 1 is what? Yn minus 1. See, del of yn is not possible here. Why? Because I do not have yn plus 1 at all, because the set of points given to me goes from y0 to yn. There is no yn plus 1. Therefore, the question of del of forward difference of yn does not arise at all. Right? So, I then I find out the second order difference. These are called as first order differences, and it is denoted by del of yi's. Right. So now if I find out the difference of first order differences, then I get second order differences. So it is denoted by del squared. So I write this del squared of y0 as del of del y0. That will be what? It is del of y1 minus del of y0. Right? Del of y1 is what? y2 minus y1 minus del of y0 is what? y1 minus y0. So del squared of y0 is defined as what? y2 minus 2y1 minus y0. Basically what it is? What is del squared of y0? It is the difference of first order difference. That gives me second order difference. Likewise, I can define del cube of y0. What will be that? Difference of second order difference. That gives me the third order difference. So like that, I can define higher order difference, right? And I can formulate, or I can tabulate this forward difference in the following format, and I call that as forward difference table. So first column consists of your arguments, that is independent variables, x, x0, x1, x2, x column, x0, x1, x2, so on up to xn. Then the second column consists of corresponding values of y. Say in front of x, I write y0. x0, I write y0. In front of x1, I write y1. In front of x2, I write y2. So like that, I go up to xn, yn. Then in between y0 and y1, I write the first order difference of y0. That is del of y0. Then in between y2 and y1, so I write del of y1, that is y2 minus y1. So like that, I go up to in between yn and yn minus 1, I write del of yn minus 1. So like this, I can write then del y1 minus del y0. So that gives me second order difference, second order forward difference. That I write in between del y0 and del y1 value. Then in between del y2 and del y1 value, I write del squared of y1. So like this, I go up to nth order difference. So basically, it looks like a bilateral triangle, right? So the base starts from y is equal to y0, y1, y2, so on up to yn. Then it converges to del raised to n y0. So if you observe the upward, see, if you observe the diagonal, see, this is del of y0 is in the y0 is in the first column. Then immediate next column, in the second column, what will be the value? It is del of y0. Then next in the third column, del squared y0. In the fourth column, the first element is del cube y0. So if you go along, what you observe here is, if you go along the diagonal, you get del y0, del squared y0, del cube y0, and all on the similar line. If you consider y1, if you go along the diagonal, see y1, this will be del of y1, this is del squared y1, this is del cube y1, like that. So what you observe here is, along the diagonal, right, starting from the top of the first column up to the bottom of the nth column, right? If you go along the diagonal, the value remains the same. It is del of y0, next is del squared y0, del cube y0, so on. The second, if you consider del of y1, del squared y1, del cube y1, so on. So like that, you can just observe the similarities here. So this is about forward difference and forward difference table. How to write forward difference, how to define forward difference, and how to write forward difference table. On the similar lines, see, as I told you in my forward difference definition, instead of considering the forward value, if I consider the backward value, see, for example, if I consider backward value of y1 is not y0 is not possible, because I start with y0, y1, y2, so on. So backward value of y0 is not possible. Suppose if I consider y1, so backward, the previous value of y1 is what it is y0. If I find out the difference between these two, that is y1 minus y0, that gives me the backward difference of y1. Similarly, if I consider y10 value, what will be the previous value? It is y9. So the difference between y10 and y9, y10 minus y9, that gives me the backward difference of y10, because I considered the previous value of y10, that is y9. So y10 minus y9 gives me the backward difference of y10. So this is denoted by the inverted triangle. It is called as nabla. So nabla of y1 will be what? It is y1 minus y0. Nabla of y2 is what? It is y2 minus y1. Nabla of yn is what? Yn minus 1. See, as I told you, nabla of y0 is not possible. Just as in the case of forward difference. Del of yn is not possible because I do not have the next value of yn, because only up to yn you are given the points, you are given the value. On the similar lines, in case of backward differences, nabla of y0 is not possible. You cannot find out nabla of y0 because you do not have previous values of y0, because y of minus 1 you do not have. That's why nabla of y0 is not possible. It starts, backward difference starts with nabla y1, nabla y2. It goes up to nabla yn. Then on the similar lines, we can define higher order differences. So differences of first order backward difference gives me the second order difference. Difference of second order backward difference gives me the third order backward difference. So like that, I can find out the higher order backward differences and I can tabulate them as follows. See, first column consists of x0, x1, so on up to xn. The second column consists of corresponding values of y, that is in front of x0 I should write y0, in front of x1 I should write y1. So I should write up to yn. Then in between y0 and y1, so y1 minus y0, I should write nabla of y1. Basically, if you observe, see, nabla of y1 is same as del of y0 of forward difference. See, in case of forward difference, y1 minus y0 is what? It is forward difference of y0, that is del of y0. But here, the same value y1 minus y0, I take that as nabla of y1, that is the backward difference of y1. Similarly, y2 minus y1 gives me nabla of y2. y3 minus y2 gives me nabla of y3. So like that, yn minus 1 gives me nabla of yn. And as I told you, in between y1 and y0, I write nabla y1. y1 and y2, I write nabla y2. Like that, in between yn in my yn minus 1 and yn, I write nabla of yn in my third column. Then again, the difference of the first order backward difference gives me nabla squared y2. So that I write between del y2, nabla y2 and nabla y1. Then nabla squared y3 I write between nabla y3 and nabla y2. So like that I continue and I go up to nth order backward difference. See here, if you, what is your observation? If you look at the last bottom line, see, if you consider yn, then what will be your next diagonal element? It is a nabla of yn. What will be the next diagonal element? It is nabla squared of yn. So if you go along upward diagonal, so that value remains the same. First value is del yn, second column element will be del nabla yn, third column element will be nabla squared yn. So like that. So if you go along upward diagonal, you get the backward differences of different orders, right? Just the reverse the case of forward difference. Reverse of the case of forward difference. In case of forward difference, it was top to bottom. If you go from top to bottom diagonal, you get the values of y0 of different orders. In case of backward differences, it is bottom to top diagonal gives the same value. Maybe the orders are different. So this is how we define the backward difference and we define the forward difference table and we write the forward difference. Basically, if you look at the forward difference table and backward difference table, they exactly look like same figures, same numbers will be there. Only the problem is what? The notations. In case of forward difference, I make use of del of y0, del of y1 and all. In case of backward differences, I make use of nabla, nabla y1, nabla y2. I go up to nabla yn. So that is the difference. Otherwise, numerically, if you look at the table, backward difference table, forward difference table, they will be exactly similar, right? So with this idea, I'll go to the next topic. These are not there. Just you can go through it. It's the relation between the forward difference and the backward difference. I make use of the shift operator. Then I find out the relation between forward and backward difference. And I can even relate the for shift operator and differentiation, differential coefficient. D is d by dx. See, you know, f of x plus h by Taylor series, I can expand f of x plus h as what? F of x plus h by 1 factorial times f dash x plus h squared by 2 factorial times f double dash x, so on. So that means it is 1 plus h into d, means d I f dash x I write as d of fx. As in the case of differential equations, I replace d by dx, d squared by d squared y by dx squared as d squared, so like that. If I make use of such notations, I can write this as what? E plus 1 plus hd plus h squared d squared plus h cube d cube, like that I can I can write, right? So if I know that if I consider the Maclaurin series expansion of e power hd, I can write 1 plus hd plus h squared d squared plus so on as e raised to hd, because e raised to x expansion is what? 1 plus x squared plus x cube plus so on. So if I use that, I can write this as e raised to hd of fx. That means if I consider, if I look at this, e of fx is e raised to hd of fx. So the shift operator e, I can replace by e raised to h into e. H is what? It is common difference. Common difference into d is capital D is what? It is d by dx. It is the relation between the operator d, the differential operator d, and the shift operator e. Anyway, it is not there in the syllabus. Out of curiosity, if you want to go for higher studies and all, definitely you require all these things in preparation of your GATE examination. Right. So for that, from that point of view, I have kept this just for your reference. Then I go to Newton's forward interpolation formula. So here the statement is, if x naught, x1, so on to xn are given set of observations with common difference h, y naught, y1, y2, so on up to yn are their corresponding values, then y is equal to f of x can be written as what? F of x is equal to y naught plus p times del y naught plus p into p minus 1 by 2 factorial del squared y naught plus p into p minus 1 into p minus 2 by 3 factorial del cube of y naught plus so on, plus p into p minus 1 into p minus 2 so on up to p minus n minus 1. If I simplify this bracket, I can write this as what? P minus n plus 1 divided by n factorial into del raised to n of y naught, where p is what? It is x minus x naught by h. So x naught is what? X naught is the first value in the table, first value of x in the table, and x is what? It is the point at which you are required to find out the value of the function, right? So that so for that you are required to use this formula. This is called as forward interpolation formula, because you are using forward difference, that is values from the forward difference table. This is del of y naught, del squared of y naught, del cube of y naught. These are all. Del of y naught is what? First order forward difference. So del squared of y naught is what? It is second order forward difference. Del cube is third order forward difference, so on. Del raised to n is nth order forward difference. That's why it is called as Newton's forward interpolation formula. Anyway, the proof is not there in the syllabus, but you just you go through, as I told you. If you are curious, if you are interested, you can go through this and you can just derive these formulae. It's very simple, right? So you can go through it. As far as the syllabus is concerned, you are required to remember this formula. We don't give you such formulae in final exams. You should know what is Newton's forward difference formula. Newton's forward difference formula is given by f of x is equal to y naught plus p times del of y naught plus p to p minus 1 by 2 factorial times del squared of y naught. So it should be, you should remember this formula. What is p? P is x naught x minus x naught by h. That gives me the value of p, right? So that you have to remember. Otherwise, the proof is not required for you. So with this, I go to Newton's backward difference formula. It is almost very similar to Newton's forward difference formula. Their negative was there, here positive is there. Their backward difference is forward difference is there in Newton's forward difference formula. Here the backward differences will be there in the Newton's backward difference formula. The statement is, if x naught, x1, so on up to xn are given set of observations with common difference h, and y naught, y1, so on up to yn are their corresponding values, then the value of the function is given by f of x is equal to yn plus p times del of yn plus p into p plus 1. Here if you observe, see, p into p minus 1 by 2 factorial was there. Here it is p into p plus 1 by 2 factorial del squared yn. The next is, here if you observe the forward difference, it is p into p minus 1 into p minus 2 by 3 factorial is there. But here it is positive, like p into p plus 1 into p plus 2 by 3 factorial times del cube of y naught. It is nabla cube of y naught. There it was del cube, here it is backward, nabla cube. So like that, it is nabla raised to n of y naught finally. So this is your backward difference formula, Newton's backward difference formula. Again, I have given you the proof here, but it is not there in the syllabus. But you should remember this formula. F of x is what? Yn plus p times del of yn plus p to p plus 1 by 2 factorial times del squared of yn, so on, p into p plus 1 into p plus 2, so on to p plus n minus 1 by n factorial times nabla raised to n of yn. Here see, here that problem is there. It is nabla squared, nabla cube, so on up to nabla raised to n of yn. So that change you should make. It is a typographical error. Make those changes here. Instead of del squared, it is nabla squared. Instead of del cube, it is nabla cube. So on. It is instead of del raised to n, it is nabla raised to n. So with this, I'll stop now. I discussed in my today's lecture, I discussed about forward difference, backward difference, how to write forward difference table, how to write backward difference table, what is Newton's forward difference formula, and what is Newton's backward difference formula, along with the proof. The proof is not there for you. Nobody, no questions will be there stating that prove the forward difference formula or prove the backward difference formula. You are required to apply these formulae in solving the problems. Right? So with this, I'll stop now. But before I go for numerical solutions, please go through the notes once again. Those who want to go for higher studies or those who want to gain more knowledge on Newton's forward and backward differences, different formulae, please go through the proof. If you are having any doubt, you can post me either in Google Class or in WhatsApp group. I'll try to solve, clarify your doubts in the forthcoming video series. Thank you. Have a good day.